Hello. Today's online feature is how to do a quadratic line intersection. Now, I'm going to do the intersection of x squared plus 10x plus 28 and the line through minus 5 comma 4 2 comma minus 10. I'm color coded this so that you can watch the colors as I use them. So I'm going to start with blue, and I'm going to start doing this guy in blue. 2 10x. Now x squared plus 10x plus 28. Let me grab anything, and there we go. Okay, and we're going to oh, come on, be good. Oh, well, I'll start writing. Okay, so we have a equals to 1x squared. B, I'm doing 10x squared plus 10x plus 28 first. B is equal to 10. C is equal to 28. So, that means, let's color that guy up blue. Okay. H for this quadratic is equal to B, 10, divided by negative 2 times A, 1, which equals negative 5. And K, we plug it back into the formula. So K is equal to, parenthesize, always parenthesize before you exponentiate, especially negative numbers, negative 5 squared plus 10 times negative 5 plus 28, which is going to equal 3. So that tells me that my quadratic is at negative 5, 3. That's its vertex, that is. So that's the first point I'm going to drop on this guy. So we have a nice point dropper. And actually I use a mouse for that. Negative 5 is here. 3 is here. And we're going to drop down this point. And it's a 1x squared quadratic. That means we go over 1, up 1 squared. Left 1, up 1 squared. Over 2, up 2 squared, or 4, which from 3 will take us to 7. Left 2, up 3 squared to 7. Left 3, up 3 squared to 12, which is somewhere around here. And left 3 up 3 squared to 12. And that gives us the shape of the quadratic we want to draw. And now, if I draw the quadratic through those points, I'm going to get, oh, come on, give me something that's about that shape. Okay, and that's probably fairly consistent. I might want to draw it a little more carefully. I can do that again. Let's try it again. Yeah, that's a little neater. Okay, and now I'm going to switch to red math to do the line. Now the line is going to have 2 points, and we always want those points to appear in our graph. Negative 5, 4. Oh, come on, give me that. Okay, get that. Negative 5 over here, 4 right here, and 2, negative 10 down here. So whenever we do a line, we make a triangle, and we do some counting. Okay, so to go from here to there, okay, is going to require Oops, that's not what I wanted. Come on, be good. Alright, let's try it again. Let's see. Use that and make an arrow. Okay, so we're going to go from here to here. And that's going to be 1, 2, 3, 4, 5, 6, 7. So this guy is going to be 7. Oh, give me that. Sometimes the thing is a little bulky. Oh. I think it's drawing something, that's why it's so bulky. Give me that. Alright. Let's get into its moods. Alright, wait a second. Stop that. Stop that. Stop that. Stop that. Alright. Got it. Okay, and that'll be 7 equals delta x. And then we're going to go down. I'm just going to get lazy about this. Just go down. And this is negative 14 equals delta y. 4 and 10. And that's going to give me delta y over, honey, I'm making a movie. Delta x equals negative 14 over 7. And that's going to equal negative 2. And so, that means that I'm going to draw this guy, what I'm going to do is go over 1, down 2, from one point to the other. So I'm going to get a whole bunch of points. Over 1, down 2, 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 and that leads me to that point. So I know I got it right. That checks my work. It also gives me a hint as to what the intercept's going to be when I do it algebraically, but that's not count. Now I also go, if I go left, negative delta x is negative 1, delta y is positive 2. So I go left 1, 2, left 1 up 2, left 1 up 2. And from these points, I'll see both intersections. So now all I have to do is draw that line through all those points. There. And as you see, my stylus is not beautiful, but that gives me an idea that my answer is going to lie somewhere around here and here. And this guy down here is going to look like a little more than 3. Let's call that 3.2, and about negative 4.5. Negative 4.5. And the higher intersection is going to be of like negative, I ran out of ink, negative 7.2, and about about 9.5 or something. 9.3, let's call it. 9.3. And so that's my guess. Oops, that didn't look good. And make that. There's garbage on the screen. And we'll make sure 9.3. That's it. Now it's readable. So, that's enough of that. Okay, we'll hit escape. Escape again. And that's solving it graphically. As you can see, it's all about the graph. Now, algebraically, we need to find the formulas. Now, we start over from scratch. We never combine these two. We start over from scratch, and we just use each other to check. So we really should find the line should be negative 2x plus 10, but we're going to find that algebraically. And we don't need the formula for the blue quadratic because it's given to us. So I just need to find, first, with red, I'm going to find the slope, and we'll cause this whole thing to be red so as to match the color code. So let's do this in red. Red. Slope is going to equal, as you see, negative 10 minus 4 divided by 2 minus negative 5, which is going to be negative 2. And the intercept is going to be negative 10 equals negative 2 times 2 plus intercept. Y equals slope times x plus intercept, which is going to give us, okay, we add 4 to both sides, because negative 2 times 2 is negative 4. We're going to add 4 to both sides, and that's going to give us negative 6 is the intercept. Now, so my formula for the line is negative 2x minus 6, which matches. Now what we do is we set that equal to the formula for the quadratic, which I'm just going to cut and paste. Because what we're going to do is set them equal to each other. So we have our slope and intercept, and we have the quadratic, and to find the roots, whatever we want to find an intersection, we set the two formulas equal to each other, because the x that produces the same y in both formulas is an intersection x. Now, because this is a quadratic line intersection, there are two, usually at least two intersection points. Sometimes there'll be none, sometimes in rare cases there'll be only one, but most of the times there are two. Just like there are usually two roots of a quadratic, but sometimes there are none, and every once in a while there is one. Okay, now the first step is to create what I call the helper quadratic. Because we don't know how to solve this problem, we know how to solve problems where the quadratic is equal to 0. So I'm going to add 2x plus 6 to both sides. What's going to happen is we're going to end up with the helper quadratic, which is going to be 0 equals, yes, I know computers, x squared plus 12x plus 34. Now, if the helper is x squared plus 34, the x's that make this 0 will make these two equal and will be x's of the intersection, not y's. We'll need to get y's later. Okay, so I always solve using the HK method, even algebraically. So what I want to find is helper h is equal to b12, the helper b, over -2 times the helper a, 1, which is equal to negative 6. And then I find the helper k by plugging negative 6 back into the helper. So I'm going to have negative 6 squared. Notice that's the helper, times 12 times negative 6, that's 16, 6, plus 34, which is going to be negative 2. So, the roots of the helper roots are going to equal h negative 6 plus or minus the square root. Let me get the square root symbol out of here. Square root of parentheses negative k, that's negative 2 over a1, which, okay, so that's, okay, negative, and if you do a little algebra, negative 2 over 1 is 2. So, that is equal to negative or minus the square root of, I'll change that little thing to just 2. So, oops, always forget that. Now what I've got to do here is, now I'm going to figure out, I'm just going to plug that into my calculator. So, the first x is negative 6 plus, I'll do that one first, and that's going to give me this number. Okay, let's just round that to 59. Negative 4.59, it'll be a little rounded, but that's close enough. And then, to get the y value, I plug it into one of these original formulas. Either this one or this one. So let's start with, and it'll be, if it works in both formula, that's a check. It'll be a little rounded, so there might be a little bit of difference, but it should be close. So if I do negative plus minus 6, that should equal 3.18. So it's telling me negative 4.59, comma, 3.18. Now, I already have a little check. Oops. I did this wrong, correct? I put y in front of x. That is bad. Okay, so that's a check. And we see this is negative 4.5, 3.2, not the other way around. So, oh, it's negative 3.2. Actually, where is that hitting? That's hitting around negative 4.5 and, yeah, 3.2. And what I had is negative 4.5, 3.2. I just got backwards here. So graphically, like I said, this is a check. So what I've done is I've screwed this up. 3.2 is the point. Is that the point? Look at that. I moved the little point over here. Didn't work. Let's just leave that. 3.2, and we'll move the comma also. It goes there. I need to put a little point there. So this is wrong. But the problem was graphical. The problem is I put the X and Y switch. Now that's a fairly common problem that you should watch out for. Everyone sometimes switches X and Y's. So you see, even I do that. Okay? Now I see that these two line up, and in fact that point that I circled is really negative 4.5, 3.2. Now, let us also check by plugging it into the blue formula here. So I'm going to take parenthesizing, always remember to parenthesize before your exponentiate, negative 4.59 squared minus 10 times negative 4.59 plus 28. Ah, that's wrong. Maybe I was wrong. Maybe I'm checking this wrong. Oh, this should say plus, though, not minus. So the problem was not. This is a common problem also. An error in my math. It was an error in my check. I make all of these errors every once in a while. So if I say equals that, now it's about the same, about 3.2. It's a little different, but given that I rounded, it's close enough. Let's get the other answer, and let's try not to make errors this time, because it's me that I'm talking to, but that's okay. Negative 6 minus square root of 2. Aside from typos, I'm going to make those no matter what. And this is saying about negative 7.41. Round that to 2 places again. Okay, now it's saying negative 2 times negative 7.41 is going to equal, that's not enough, plus minus 6 is going to equal 8.82. That's right. Okay, now, if we scroll back, I said negative 7.2, 9.3. This is, by the way, not uncommon. It's a little hard when both lines are moving more or less in the same direction to get the exact answer. But it's fairly close to what is going on. Negative 7.2, negative 7.4. The 9.3, the vertical is sometimes a little inaccurate, but it's close enough. Let's just make sure. So this is a case where we really have to check it algebraically. But this is what it's saying. Our answer is negative 7.41, comma, 8.82. Let's see. If it checks algebraically, I'll believe it. So we'll have negative 7.41 times 10 times negative 7.41 plus, and what am I adding? The blue formula says it's plus 28. And that's going to give me 8.8. Yes, it's almost exactly right, so that's a check. And this one is also a check. And they all check out. Okay, and so that's the answer to this question, which originated as a quiz question. But I think it's useful for everyone to see how you solve this line intersection, because it usually appears on an exam as well. And that is